What does it mean for a function to be differentiable? Well, the answer is actually quite simple. A function is differentiable at a point if it has a derivative there, if it has a derivative at that point. That's all there is to it. In other words, by the definition of our book, a function f is differentiable at x if this limit quotient, or limit definition of the derivative, exists. Because, if you remember, that is the definition of our derivative. And since the value of the limit and the slope of the tangent line are both the derivative of f at x, so this is also the slope of the tangent line, what we're going to do is we're going to look at the slope of the tangent line. So obviously, if the function is not continuous at a point, it doesn't have a slope. So that's that one. The graph has a sharp corner. So if it has a sharp corner, you're going to see that's like a teeter-totter. It doesn't have a slope. Or if you have a vertical tangent, well, that makes sense. The slope of a vertical tangent line is undefined. So let's look at a couple of examples. So we're going to try to compute the derivative of this function, absolute value of x, at x equals 0, and we're going to see if it's differentiable there. So since the absolute value of x, by definition, is x if x is positive, and negative x is if x is negative, we can easily graph it. We get a line this way and a line that way. You can see that there's a sharp point at the bottom. So the answer is going to be no. So let's go ahead and see that. Let's try to compute the derivative at that point to see what fails. Why is it a no? So we'll write our definition of our derivative at x equals 0. And then I'm going to plug that in. And I get here a absolute value of h, because that's just f of h, minus 0 is 0, all over h. We've seen this before. The answer was this didn't exist. The left did not equal to the right. You can see why, because when you're going on the right side, 0.1, this would be 0.1 over 0.1, right? 0.01 over 0.01, and even 0.001. But on the left, if you look at negatives, the numerator would be positive 0.1, but the denominator would be negative. So you can see that the left is not equal to the right. You can also tell from the slope of the tangent line. Coming in this way, from the right, the slope is always 1. Coming in this way, the slope is always negative 1. So the slopes are totally different. It's like a teeter-totter at that point. What would be the slope? You can see that f prime of x is 1 if x is positive, negative 1, the slope of the tangent line, if x is negative, but right at 0, it does not exist. So that is the answer. So let's look at another function, another example. Investigate the differentiability of f of x equals x to the 1/3 at x equals 0. So if you graph this, you can see that there is a vertical tangent here. So it looks like it's not going to exist as well. So that's that second one, if it has a vertical, or the third one, if it has a vertical tangent. So we've checked out the sharp corner, and now we're checking out that vertical tangent. So let's look at the definition again of f prime of 0. And what is this going to be? So now we're going to plug in f of h, so that'll be h to the 1/3. F of 0 is just 0 over h. So that would be 1 over h to the 2/3. How did I get that? I can subtract these exponents. It'll be negative 2/3, so it's 2/3 in the denominator. Or just bring this down here. Which, by the way, as h goes to 0, this is going to go to infinity, isn't it? and infinity does not exist. So as h goes to 0 on the right, it becomes a positive infinity. As h goes to 0 on the left, because of that squared, it becomes a positive infinity. So I do know that the limit is positive infinity. I get that, but that still does not exist. If I look at our formula of f prime of x in x to the n minus 1, where f of x equals x to the n, we can actually find the formula here. And you can see if you get 1/3 x, we're going to take 1/3 minus 1, and we'll get, that's where we get the 2/3, negative 2/3. So the actual formula for the derivative, because this is just giving you the derivative at 0, but actually the formula for the derivative is 1 over 3x to the 2/3, and you can see at f prime of 0 is undefined. So f is not differentiable at x equals 0. So now we've done the vertical tangent. Let's go back up here and look. We did the sharp corner. We did the vertical tangent. We did the sharp corner. Sharp corner, I never said, but the answer here was no. It's not differentiable. So it's not differentiable at a sharp corner. It's not differentiable at a tangent line. So now let's look at a function that is not continuous at a point. Is f differentiable at x equals 0, where f of x equals 1 over x? That is not continuous there. If you remember, this looks something like this. If you graph this on your calculator, you'll get something like that. And you can clearly see that f of 0 is not defined. So f prime of 0 is also undefined. There's no tangent line at a place that's not even continuous there. So clearly, f of x is not differentiable at x equals 0. So now we've done all three. Get back to the top. If a function is not continuous, it's not differentiable. If a function has a sharp corner, it's not differentiable. And if the graph or the function has a vertical tangent somewhere, it's not differentiable. That's 3 places where it fails. So let's look at one more example. Example 3 in the book, a piecewise function. So the difference between continuity and differentiability. So it says draw a graph of G. Is G continuous? Is G differentiable? So I'm going to graph this line for x is less than or equal to 1, and then this line when x is bigger than 1. So x plus 1, so it starts at 1, it has a slope of 1, and then when x is after 1, it starts at 2, and it has a slope of 3. So you can see it's continuous. If you remember from continuity, we just looked at the function value, the limit as x goes to 1 of the function value if it equals to f of 1. And it does, because we look at the left, it would be this function. So that would be 1 plus 1, which is 2. And we look at the right, we look at things larger than 1, so we look at the second value there, and that would be 3 times 1 minus 1, which is also 2. And if you look at g of 1, which we already actually computed here, because that would be right at the top one there, 1 plus 1. All 3 of these values are the same, so you do have this. The limit exists, it equals to 2, and it's the same as g of 1. It's all fine. There's no holes, everything is good. Now looking at differentiability, we're looking at the difference quotient. It's a little bit different, isn't it? And to see if that limit of that difference quotient at 1 exists. We got to look at the limit as h goes to 0 from the right and from the left. And from the right, that means things are a little bigger than h. So we're going to take our h to be on, when h is 0.1, we'd have something to the right of 1. So the slope, and we know it's the slope of the tangent line. So the slope at the tangent line at larger than 1 is 3. And you could actually go and figure out this difference quotient using that line if you wanted. Just make sure you come in from the right only. When we come in from the left, this would be over here, something over there would be 1 plus h on the left when h is negative, because it would be like 1 minus 0.1, 0.9, right? And then we would look at things that are a little smaller than 1, so we end up taking the top graph, which the slope of that tangent line is 1, and these are not the same. So the answer is no here. It's not continuous. So we can see a sharp point, so we know it was no, and the answer to this one was yes. This one is no. If you want to see the work here, just plug in a 1 plus h into something to the right, because we're doing to the right. 1 plus h there, so it's 3, 1 plus h minus 1, and then subtract g of 1, which we found up here is 2. And you're going to see here that you get the 3 because the 3's cancel and then the h's cancel. All good. And if you want to see the work for this one using the quotient limit, this would be plugging it into, again, the first. We plugged it into the first one because the h was a little smaller. A little smaller than h again is like negative 0.1, so g would be 0.9, right? It would be smaller. So I would plug it into that second one. These are pluses. And that would be 1 plus h into the top one minus 1. Then plugging in the, that's what that would be. Plugging in the g of 1 there would be the 2. Oops, I'm at plus 1 there, didn't I? So 1 plus h plus 1, and then minus the 2. You can see there that the 2's cancel, the h's cancel. That becomes a h over h, which is indeed 1. Hope that helps.